Once again, I want to welcome you to today's EnRoute webinar. Today we'll be hearing from Aaron Clapp. He is the Director of Training here at SAI, and he knows EnRoute inside and out. And today he'll be showing you how to use the Fine and the Clean tools in a toolpath with EnRoute. So he's got several different examples, scenarios to go over, kind of show you the ins and outs of that. And then after the presentation, we will have a Q&A session. So if you do have any questions about using those tools or just any other questions about EnRoute in general, you can go ahead and type those into the window there, and he will answer those, as many of those as we can. And last note, we will be recording this webinar as usual. So if you have to step out or you want to share this with someone else, we will send you a link to the recording when we post that on YouTube. And I think that's everything. So we'll go ahead and turn it over to Aaron.
All right, thank you very much. All right, so let's just get jumped in here, and I've got my screen shared here, so you can kind of see some things I'm going to be doing. So the whole idea of clean and fine, let's kind of define what that kind of means, how to set that up, and then where some good examples of what would be some good examples for how to use clean and the fine toolpaths. So the first thing I'm just going to do is I'm just going to jump into a toolpath that I've already created here, and we're going to kind of look at how do I add these in. So I'm going to grab this, and I'm going to just remove the toolpath here. First of all, I'm just going to start out with a regular routing offset. I'm going to clear this out just so that we have a fresh start here. So the definition basically of a clean and the fine, what do those basically do? Well, in EnRoute, when you add a tool, and we're just going to throw in our 1/4" end mill here, you typically will see this label right here called rough. That is a general term for your average hogging out type cut. If you add a second tool, and this could be any tool, we get these labels, clean, and then you might even get another one that says fine. So you might see something like this in here. The clean takes the approach of going over the same space that the rough tool went over, except for it's going to be removing a little bit of material that the rough pass intentionally left behind. And the fine tool is kind of similar, but it's not going to go over the entire tool path. It's actually just going to fit itself into the little nooks and crannies that the 1/4" end mill couldn't fit into. This is going to be really useful for cleaning up the insides of letters and corners where that 1/4" end mill just won't fit very well. Really useful for smaller type letters and things like that. So if we delete this tool, we can switch this to a fine toolpath if we're using the internal here. And similar parameters that you'll see with a lot of the other things like your feeds and speeds and whatnot. So let's jump into some kind of real world examples here that I have set up already. So here we have one of our classic examples is going to be, this is what your standard routing file is going to look like. Your typical external routing offset, no clean pass or anything, just going to be cutting around the edge and getting into those corners. The clean pass is going to look like the second example right here that I've highlighted. So we can see that we have two different specific tool paths that are laid out for us here. Now, if you compare this toolpath here with this one over here, the blue line is actually offset just a little bit, what this does for us is that by default, EnRoute will offset half the diameter of the smaller bit in order to leave a clean pass for it to follow. So if we dial into this one here, I'm going to right click and edit toolpath. I can see that I'm using a 1/4 inch end mill and a 1/8 inch end mill to clean this up. If I dial into the settings here under edit, I can open up the width section, and here's where I can define how wide I want that clean pass to be. So in this case, it's half the diameter of our 1/8 inch end mill. I can make this bigger or smaller, and the software will automatically compensate for the larger bit and push it in or out depending on how wide I make this. So if I make this 0.1 inch, for example, we'll see that it pushes out our other tool path a little bit farther so that it leaves that extra amount of material for this bit to come through and cut. Now our green tool path is not going to move really in this case because it's still cutting out what it can. So depending on what kind of materials you're cutting, you may want to make that a super thin pass, or you may want to make that really, really wide, depending on whether you're cutting acrylic or wood or certain things. If you're just looking to kind of cut that last little bit off and just make that edge smooth, typically you're going to make that a pretty small setting. Now, on the contrary, if we look at the the FineToolpaths do not go over everything again, but rather they just come in and they add a little bit of cleaning up in the areas that are only needed. So in this case, our end mill can cover everything, except for when it gets into these little tight corners here, that 1/8 inch end mill is going to assist our larger bit in just cleaning up these little areas. This is really helpful if all you need to do is just clean up those little notches, make those a little bit better, but don't necessarily want to run the entire bit over the entire file multiple times. I'm going to edit this toolpath and kind of help us take a look at that. And the way that I have this set up is an 1/8 inch end mill rough cut, and then an 1/8 inch end mill set to fine. And we'll just hit the edit, and we just changed that from here as well. Now, these end mill or these the fine tool path is restricted to, you have to have a bit that's smaller than the original to do a fine tool path. Whereas if you're doing a clean tool path, you can actually assign the same bit twice and it's not a problem. So if I go back to here, I can actually remove this 1/8 inch end mill. And if my entire goal is just to have a clean pass to remove that thin layer of material, I can just re-add the same tool again, and that's not a problem. It'll put it in as a clean pass. So I can actually use the same tool twice. Once to go on the outside and leave a little bit, and then the next one to come in and finish that up. Here's an example of the same process, except for using an internal cut. This is going to be really helpful using the Fine Toolpath, and this is a really good example. If we were to preview, we can see that our letters here are just small enough in some of these areas where our 1/4 inch end mill is just not going to fit. So this is going to be helpful to have a smaller bit that we can come in that can just kind of clean up those areas that were left behind by our first bit. And I'm going to come in here and I'm just going to 3D preview this so that we can kind of take a look at this and see what that's going to look like. So you can kind of see here in our 3D render that obviously our 1/4 inch end mill obviously couldn't fit into some of these places. We have an incomplete letter, but when we add our clean tool or our fine tool, pardon me, we're going to get a completed letter that doesn't leave the bit cutting out in a bunch of open space already. That's kind of one of the things that's nice about the Fine tool, is that it's all about efficiency. So your cutting is going to, it's not going to give you a way increased cutting time simply because it's only going back and touching up the little areas here. Let's take a look at another slightly different example. I've got an island fill here with a standard cut. This is real similar to the routing offset. This is just going to cut out a standard old cut, so nothing real complicated here. But when we add another tool, this is where it can kind of get a little bit interesting. I've set up some layers here. So I've got my same toolpath. This time I added an 1/8 inch clean. So what this is going to do in the island fill is it's not going to go all the way back over all this middle stuff. It's only going to go back over the areas that have a contour associated with them. So in this case, the E, the R, the inside of the R, and then the outside of the letter are going to get cut with this other smaller end mill. So let's just see, and then we can kind of preview this just to kind of give us an idea of, and why don't we turn on these two layers together, and we'll just kind of look at the difference here between the two and see what we have, just for a visual reference of what we got. So the difference isn't a huge amount here, but if you look real closely, some of these internal cuts here have a little bit smoother edge, where like specifically here, you can kind of see this little notch right here. There was a weird little thing in the font here. So this one was able to kind of get in there and kind of, make that look a little bit better, because the 1/8 inch end mill can kind of clean some of that up, make it look a little nicer. So not a big difference, but there's enough that in a visual standpoint, if you're dealing with small letters, it'll definitely help, especially when the smaller the letters get, the more noticeable that kind of thing is going to be. Now let's go to our next kind of example here. This is going to be our end mill with a fine tool, and if I zoom in here real close, we can kind of see tiny little areas where it's picked up in the corners. Again, nothing crazy. We're just talking about little cleanups here. So in the grand scheme of things, this, using it as a fine, is really nice to kind of just clean up these little corners here. Especially if you're using like a really sharp edged font that looks good sharper than it does rounded, you're definitely going to want to try and use either some kind of an engraved bit, a smaller end mill, or something to kind of sharpen up those inside corners, because you'll get a little bit of a strange look when you have sharp outside corners, but then you have like really rounded inside corners. So using that fine toolpath is going to help a lot in that particular circumstance. And again, the way that we set this up is the same as before. We simply added our first tool, and then added the second tool, and then clicked on here and changed it to fine. And that was all we did there. Let's mix something else in. Let's do something that's a little bit different. So now we're going to start mixing in some things like an end mill and a conic bit. So what I've done here is I've added two tools. The one is going to be my 1/4 inch end mill, and the other one's going to be my 9-degree conic. So the goal, or what my idea here, what I wanted to do was I wanted to have the R and the E stand out from the edge of this part, and then just have this kind of flattened out, and give a little bit of a taper to these letters so it doesn't look so abrupt. It's not just a bunch of square letters sticking out of the piece. I can add my 1/4" end mill in the same method. I can add a clean on this, and it's just going to go all the way around the edge of the part and just kind of give me a nice beveled edge. So if we were to preview this, I'm going to actually preview both of these because this one here is going to show us a little bit of an interesting thing in regards to the effect that it gives us, but how much longer it takes to cut. All right. So now you can kind of see here that I've got a nice kind of 3D-ish looking letter. It's got a nice kind of bevel to it. Nothing crazy, just kind of a nice smooth transition between the flat bottom and the top surface. Kind of gives me a nice smooth look to it. Much better than just a straight up and down simple cut. There are good times for that, but in this case, this is the look I was going for. And so adding it as a fine toolpath or a clean toolpath allows me to kind of shave off those edges just a little bit to kind of get that nice taper. Over here, I used a real similar tool on the right-hand side. What I did here was I actually used a tapered bit for this, mainly because the tapered bit has like a flat bottom or flattish type bottom, depending on how the tools are configured. But this one I used to cut the entire base of it out as well. So I got a real similar look, not quite as angled. So it's a little bit steeper, but there is still a little bit of an angle there you can kind of see. But the difference here, though, is that when we look at the toolpaths, let's go back to this screen, we notice that, yeah, I used one tool, but it like double or tripled the amount of tool pathing that it took. So this was just a 60-degree tapered bit that I used here, and this is going to take a long time. You can see how close these tool paths are together for it to be able to fill this in. So this is really ideal when you could either use a tapered bit or a conic, either one would work, but you want to use one of those as your fine tool or your clean tool versus you just using it to hog all this out. This obviously is going to take much less because you're using that flat bottom end mill to kind of clear out all that material and then come back later and just do a real quick pass with the letters versus this where you're just going back and forth and back and forth and doing tons and tons of passes to achieve something similar that can be done in a quarter of the time. So this can apply to a lot of different things, adding these different fine and clean tool paths. You can also use this kind of thing in 3D to a certain extent as well, using multiple bits to do a rough pass and then a clean pass, and therefore reduce the amount of time that you have to use to cut and increasing the detail of your cuts as well. Let's do another example here. Here's an internal cut that I set up here. So these are an 1/8" end mill with a 60-degree conic clean on this one. And then on this guy, I believe we used a 90-degree conic. So I made these a little bit larger letters because that 90-degree conic doesn't like to fit quite in this little one. So I made these a little bit bigger. But let's preview these and kind of see what they look like. So the idea here is going to be that I want to, instead of having the letters stand out, I want those letters to be pushed in. But I don't want that weird thing that can happen when you use a conic tool. If you run the edge of the conic, you get like a little pyramid shape in the middle where the tool didn't reach. In fact, I think we can just replicate that here so we can kind of take a look at it so you all know what I'm talking about. Let's just take away the 1/8 inch end mill. And let's just preview all three of these. Yeah, it looks all right. So this is kind of the effect that happens when you're going to get like leftover stuff in the middle when it just goes around the edge. And that's what that end mill, if we set it up as an end mill with an end mill first and then a clean later, then I can kind of come back and clean this up. So notice it's got a nice flat bottom to it. I don't have any pyramid shapes left over in the middle. Let's actually just take this and duplicate it. And let's just remove the end mill on this one as well. So we just have that conic bit there. We'll expand the reaches of our preview. Here's a kind of a good example of what I'm kind of talking about when we're looking at creating beveled letters that go into the material. So you get this typical type thing here where you've got these little peaks in the middle because all we did was we sent the bit around the edge and now we've got all this weird material that we want to clean up. That's where instead of using the conic bit as the main tool, we switch it to having it as the secondary tool. And now we can get this nice, clean bottom to our letter with no peaks or anything in it. And we get a nice smooth edge to our part. So using those FineToolpath and EnRoute in combination with other tools can help you create a lot of cool little effects like that, and can really kind of help you with creating engraved letters that look really nice and that look like you spent a lot of time doing 3D, but you really didn't. You just used you took the advantage of the shapes of your tools to kind of create an effect that comes off really nice. Last thing we want to kind of just go over, and this is kind of just one of those quick ones at the very, end here. You can also create shoulders using the clean pass. This is kind of an interesting concept here. I'm using my end mill to cut out this entire letter here, and then I'm also using another end mill to carve out like a shoulder or a lip in case you need to do like push through letters or something like that. Let's take a look at this toolpath. I'm using the same tool here, except for what I'm doing here is on my rough pass, I'm actually setting that to go all the way through the material at 0.75. And then I'm coming back on my clean pass and saying I only want to set this at 0.5 inches. So I'm going to have a 1/4 inch lip at the end of my cut. And the way that we take a look at that here, we'll kind of see this in the preview, is we're going to get let's increase the resolution here just a little bit, give us a little more detail. And it's going to be a little bit tricky to see. Well, I guess not too bad, but now you can kind of see what we've created. The outside cut is going to cut all the way through the material, but then the inside clean pass is only going to remove a portion. So now if you are doing some kind of push through letter or something like that, you could create that very easily, recreate that lip that you need to so that the letters don't fall through. The way that I define that depth there is going to be, go to our toolpath again. All right, so I added my bit in here. We're not going to really mess with that a whole lot except for just give it our depth. When we define the depth here, I'm going to go into the define cut tools. And basically what I did here was I changed my width of cut to 0.25 inches. I could make this as big as I want. I could go even up to 0.5. inches on this particular one. And depending on how wide you want that shoulder to be, we'll just go in and set that up in here. So you can kind of see here, it's not showing real clearly through, but you can kind of see that, did it not, looks like it didn't do that outside cut. Maybe I stopped it short or something. Let's take a look at that again, make sure that 0.75. Let's just change this to 0.76 to make sure. Let's let that render fully before we. All right, my render is being a little bit weird, but for some reason it's not showing all of my tools. But anyway, so the idea is that I can increase that shoulder. So if I look at the difference between the space here and the space given here, this is a lot wider than it was on the other one. So Toolpath is there, but I don't know why it's not going through. Probably just a rendering error there. But that's another easy way to create a shoulder for a part. So you can kind of see that EnRoute has a ton of different things that you can use this for. Again, the limit, what you can do in different types of tools. For example, you could insert some engraving tools in here, and that can help clean up in corners really closely, especially if you have really tiny letters that you're dealing with. Really helpful in those types of scenarios. You've got your tapered bits that have like a kind of flat bottom on them. You've got that you could add to these fine and clean toolpaths. You can use the same tools. So there's a lot of flexibility in terms of how these can be added. But essentially, your main core of what we're going to do is you add the first tool, you add the second tool, and then you can define what you want it to be, whether you want it to go back and clean up everything, just the little spots, or you can go back and remove material so that you get that nice clean, crisp, smooth edge. This is really helpful. I found that people do a lot of this with like acrylic and stuff like that, where they go back with another tool that's much better, much sharper, and they'll set it up to go past that last little bit to kind of give them that really nice, smooth finish. So I think that basically covers everything for the toolpathing. I think at this point we can open up for questions and find out what we got in terms of that. So let me take a look here.
Okay, looks like we already have a couple questions. Ulysses said, I occasionally use white oak to route signs using 1/8 or 1/4 double flute bits at about a depth of 0.125. More often than not, the debris or sawdust from the routed letters gets stuck inside. What's the best way to get that cleaned up?
Okay. So typically your vacuum table would take care of most of that, but the clean pass is probably going to be using the clean pass, even if you're not cutting very much off, and using the same bit could probably help with that. Just for the fact that it's going to be going over the same area twice, pretty much. I do know that, you see, you're using a double flute bit. Sometimes using an upcut bit might also help with that. I know sometimes, depending on the material though, if you're using some kind of White oak, okay. You might use an upcut bit to help better with the removal of the chips, or something like that as well. Now, the only thing you have to worry about that would be potential damage to, like if you were cutting some kind of laminated material, the upcut bit can tend to want to pull up on the surface. So, that might cause some other issues. If you were to set up a clean pass with it, with a really super thin second pass, you'd almost be going over the same area twice, which would help pull up and clear some of that material out. So that's probably what I'd suggest there. I think that would probably help. But using your different types of bit might also be helpful as well. I do know that they make those compression bits that have a half of a down spiral and half of an up cut to help with removal of material. So they've got a down shear on the first half of the bit to help you carve into the material without pulling up anything like laminate or wood grain. And then once they get past that, that uses an up spiral to help pull the chips out. So that might also be something that might be in the cards for you as well.
Okay, he also had a follow-up. He said, does the speed of the router and the speed of the spindle play a factor in that? If so, what would you recommend?
It can. One of the things and one of the interesting tools that you can use in EnRoute under the solutions menu is what they call feed rate. This is a chip load or a feed rate calculator. So what you want to do is this is to optimize the cutting ability of your bit and what feed rates you should be using for that type of bit. So you'll put in your chip load, the RPM, and the number of flutes, and it'll calculate what feed rate you should be using for that bit. I put this kind of low, but it'll give you a feed rate. So this will kind of help you get a good feed rate. But yes, depending on the bit, the spindle speed, you might be going too fast for that bit or for that type of material. You may want the bit, instead of shaving and creating so much dust, you may be able to get away with it carving out bigger chunks so that it pulls bigger pieces versus just creating sawdust pretty much. So feed rate and spindle speed could affect that a little bit. So I might check with the bit manufacturer and see if there's some things there that you might want to adjust. If you're going too fast for what the bit recommends, you could kind of create a scenario where it causes super fine dust, where instead of grabbing chunks of material and pulling it away, feed rate can also make a difference. So I would say if you're going higher on the spindle speed, you might increase the feed rate a little bit so that the feed rate matches the spindle speed, so to speak.
Okay. We had a couple other people saying that they use a blowgun and a
Yeah.
vacuum, but it can still get stuck inside the letters. Oh, and William, yes, we will. We are recording this webinar so that you'll be able to view it again whenever you like. We will post it on our EnRoute YouTube page, and we will also send out a link in an email to everyone that registered for the webinar. We had a question from Nathan. Said, if I just wanted to smooth over an acrylic letter face, what would the width of the clean pass have to be? Keep in mind the faces still have to be a set amount larger than the aluminum letter backs.
Let's see here. Are you referring to like, let's see, if you were wanting to cut over on top of the letters to like in our example here, if you wanted to cut the top of the letters off, is that what you're referring to when you say the smooth over the acrylic letter face? Oh, okay. Yeah, gotcha. So in that case, again, this is probably if you're needing to do like a smooth pass on a like for acrylic letters and whatnot, you may want to use the shoulder option. So let me see if we go back here. So this is kind of like an easy, quick and dirty way to create a shoulder for a letter. The other way, which is probably going to be a little bit better, would be to use uh, the actual shoulder option. So if we create a shoulder here, this actually changes the toolpath just a little bit so that you could create those clean toolpaths. The other way that if you have the shoulder unchecked and you just do a width of cut, it's technically still creating a shoulder, but it doesn't allow you to do those clean passes like you'd want it to. That's where you do this. If you didn't need the clean passes on the shoulder, that's where you could probably just leave that unchecked and do it this way. And that's where the advantage is there, is that it just puts in a toolpath, but checking this shoulder option would probably be what you want to do there. And then you can also control, I want to say that we could even add, let's see here if it'll let us do this. So we won't need I think we could actually even add a third bit, which would clean on top of that as well. So you could do like a double clean pass on this. That's also another option if you needed to do that as well. See what the let's reduce this just a little bit to. We're only at 2 passes. Let's see what this kind of gives us. Okay, so this looks like it's there is two toolpaths on top of here, so that's probably not what you're going to be looking for. Let's delete. Oh, let's get rid of this one here. Yeah, that adding a third tool probably is not going to work that great in this scenario. There we go. Using a shoulder toolpath is probably going to be your better option here. And then setting with acrylic, some people like to switch the direction around as well, depending on what kind of acrylic they're using, to a climb versus counterclockwise versus clockwise. That could also help smooth off those edges on there. That'll also help with smoothing out some of those edges. Let's see here. Okay, so we got a question there by Brandon here. Let's see.
It says, I would like to know about layering. For example, I use island fill with a 1/4 end mill and then clean up with an 1/8 inch end mill, and then cut out the shapes with the end mill after I have to separate my route files. I would like to know how to include them into one. I haven't been able to figure that out.
Okay. So if you're dealing with layers, if you're applying 2 separate toolpaths on 2 separate items, you should be able to add those together. So if let's just create a new file here. I'm going to copy this here, and let's just go to new file.
He said this is specifically for push-through letters.
Okay. Okay. So if we were doing, let's just take the same letter here, because we're going to do, actually, let's delete that. We're going to copy it. And what I'm going to do is, here's how we pull up layers. It's just by this little button up here. You may have to go to your setup menu, click on toolbars, and then make sure that the layer option is checked so that you see this little dialog box here. But I'm going to click on here. I'm going to say I want to go to a new layer, and then I can define, like this is going to be my island fill, and then maybe this is just going to be my internal cut. So now I can switch between layers here. I'm going to copy this.
Okay.
And so actually I'll do kind of visualize here. Right click, copy, and then importantly, when I go to my internal cut layer, I'm going to right click and say paste to active layer. So that puts it in the same exact location as it was in the other layer. And you should be able to then apply your routing offset of whatever kind it is. Let's just say we're using a 1/4" end mill. And then we should be able to go to the internal cut and use our, say we're doing our internal, you know, delete that one for now. And once we have both toolpaths, then we can turn on all layers, and you should have, or you should be able to see both toolpaths. Now in this case, I'm not sure, you probably want these files to be separate, but just because one's a push through and then one's another. If you are applying the clean pass in two separate toolpaths, so you're doing one as a, let's say one toolpath is going to be your clean pass, and the other one's going to be your, well, actually that, if you're using the same geometry, that doesn't make a whole lot of sense to do that though, because the problem that you run into is that if I apply a routing offset to this letter here, and then I use the same geometry, and then the only thing I do differently is I apply a smaller bit to it, the size of the letter hasn't changed at all. So the second bit is actually just going to cut in the air. You'd actually have to make the letters smaller for one of the files, so that you could cut that clean. That's why if you can, anytime you're using like a clean toolpath, try and put them both in the same dialog box, because then they're associated with each other and one builds off of the other. If you do two separate toolpaths, they're not really connected to each other in any kind of way in terms of the software. And so it really doesn't marry those two toolpaths together, and if you change one, it doesn't really do anything to the other. Whereas if you have them added to the same router offset dialog box, if you change the setting on one, so if I come in here and I change the width of cut here, it affects how this one cuts. It pushes it out a little bit farther, pulls it in a little bit closer. But if you have them separate, that doesn't really happen. So I would probably say use them in the same toolpath if you can, if that's what you were doing. Then that way you can just avoid having to create more artwork that you have to toolpath separately. Hopefully that makes sense.
Okay. Thank you, Aaron. So I think that's all the time we have for questions right now. But if you do have any other questions, feel free to send us an email. We're happy to help you with any of those. And if you have any suggestions for future topics you'd like to see us go over for EnRoute, anything you've just been curious about or want to get a better grasp on, let us know and we can put that into our schedule. And thanks, John. I'm glad it helped. Thanks, Brandon. We appreciate you guys coming.
I want to just say just a little plug-in for future sessions. I think we do have an advanced session on layering, so that might be kind of a cool one to tune into later on. I don't know when that's scheduled in, but I do know that we're doing some advanced layering stuff, so that'll be kind of interesting if you're looking at kind of learning more about how to do layers and stuff.
Yeah, and I believe we have the schedule posted on our events page. Let me just pull the link here for that. And I'll post that on the chat window there. It'll be thinksai.com/events. And you can look at EnRoute specifically. But our next EnRoute webinar will be, as Aaron said, about using layers, and that will be on September 17th. So that should be a Tuesday at 10 o'clock, just like usual, Mountain Time. Yeah, so September 17th will be the next one. And I think that's everything for today. We appreciate you folks coming, and we will talk to you next month. Thanks, Aaron.